comes to the second graph, that's a parabola moving up or down.
It's not.
Well, it's not. It's just a line whose slope is 1/2 whose y-intercept is 0, 0. I think it looks something like this. You guys are being a little sloppy. And I know I cheated. I did not scale my axes at all. I just don't care. I got the general behavior of this curve. So let's give it a shot. For me to compute the area between these two graphs, what's the first thing I should do?
Find a different area.
Yeah, give up. Because I don't think it's a bounded region. I mean, that area is not even finite anyways. I think when the author asked me to compute the area bounded by the graphs of these two equations, it's necessarily implied he's looking at for me to generate the area in its only one single bounded region. You guys, since I have to compute the area, can we do a couple things real quick? Number one, let's take a break and find the points of intersection. If for me to find the points of intersection, I better take the y values in the first graph, the y values in the second graph, as expressions in x, and we'll find out when they're equal to each other. That being the case, tell me how to get rid of fractions. Man, you guys are asleep. Tell me how to get rid of fractions.
Multiply by 2.
I can't hear you.
Multiply both sides by 2.
Still can't hear you.
You can't get rid of them.
Don't get rid of them because we've got a huge mistake. I mean, take the absolute value of a difference doesn't mean I got the sum of the absolute values of terms, does it? Besides that, I don't even think what I'm writing makes sense because I don't even know if x is positive or negative. I think I'm way off base. I can't just magically make the absolute value bars disappear, so what do you want me to do?
Rewrite it as
Rewrite it as what?
x minus 3 and 3 minus x, so you have 2.
I like that.
Yeah.
Don't change your ways. I might say it a little bit differently than you,
Okay.
but I'll generate equations that are equivalent to yours.
Yeah.
I'm so lazy, I do this. I think the absolute value of something is going to be positive. But the something on the inside could be positive or negative. Let me say it one more time. The thing on the inside could be positive or could be negative. You guys know tricks. Is that okay so far? Well, now that I've rewritten this one single equation involving these nasty absolute value bars as two equations not involving them, I admit the downside to this is that I've got two equations solved, but the upside is they don't involve absolute values. And in mathematics, quite often, usually in mathematics, dealing with absolute value bars is miserable. But I have, with my mathy skills, just gotten rid of them. Now I guess I'll just bring all the terms to one side. You can get rid of fractions if you want. I just don't think in this example it's that complex. Does that give me 1/2 x equals 3, or shall I say x equals 6? Over here, does it tell me that 3/2 x equals 3, which means x is equal to 2? Oh, well, I guess that must mean then that this point of intersection right here is going to be located at 2, I don't know, is it positive what? And this point right here is located at 6, I don't know, is that positive 3? You guys double check my arithmetic. Oh, by the way, in case we need it, this other corner part right here is already given as a vertex of the beam. Now, number 2, the second thing I think you and I need to do before we dive into the calculus is just to clearly label the graphs of these equations. Do you mind if I take a moment to do that? In red? In blue? And in green? Are you happy with this? I mean, I need those to put in the integral position,
Yeah.
right? Are you happy?
Yeah.
You guys in harmony, are we happy?
No.
No, we're not. Because I don't want to put absolute values in the integrand position. I think it's way too sloppy. So let's just split things up. Let's not look at the entire graph of y equals the absolute value of x minus 3. Let's just look at part of it. For example, when it comes to the ray emanating here and going off in definitely this direction, I just think that ray's half a line whose equation is much easier to deal with. And I think to the left of that vertex, I got a ray that constitutes part of another line whose equation is
3 minus x.
yeah, negative x plus 3, the opposite of what I had. This is a lot easier to deal with. Okay, no tricks. Let's see when I dive in and set up our integral. That allows me to compute the area of that region I shaded in black. I think the area is nothing without glasses. To the left of that vertex, the top curve I wrote in red is at a 1/2 x. Minus blindly the bottom curve, which I wrote in green, which is negative x plus 3. Oh, by the way, I'm integrating with respect to the variable x. And by the way, my bounds of integration are, I'm hearing my voice too much.
2 to 6.
2 to 1. 2 to 1.
2 to 3.
Yeah, how about 2 to 3? And then I'll add to this the integral that ranges from 3 up to 2. I don't remember. Thank you. Now the top curve is still my red beast, isn't it? But my bottom curve is described in terms of x values as
X minus 3.
x minus 3, in terms of the x values for lines. What do you think? You guys, please, don't let me get away with not finishing things. But in this example, am I able to get rid of not finishing? Get away with not finishing?
Yeah.
I think the main issue here is really setting up the intervals. But tell me if I'm annoying you. I'll finish if you need me to.
No, that's fine. That's the only part I was having problems with on that part.
Yeah, I can see that. I can see it's easy to do that. Anything else in the homework? I'll do whatever you like.
Can you do on question 7, just find the point of intersection? I was having a little hard time with the math D there.
I hope I can.
All right.
In the answer book, it says, by inspection. No.
Oh, by inspection? That's all I did on it, but
Something like that.
it seems like there should be a way aside
Oh,
from
yeah,
just guess and check.
I was just kind of looking at it and I could see that
And I
it
love
was
the book,
blind.
by
Yeah.
inspection.
I wanted to know exactly how to figure that out too.
Yeah.
Math.
The French technique? What's next?
Natural log.
If you insist. A natural log? Okay. Now, how do you separate out the natural log of a difference in two terms?
You don't.
You don't. So what's next?
Guess and check.
Yeah, or how about just this? 100% absolutely give up. In mathematics, with this equation in which I've got a transcendental expression being equal to an algebraic expression, I literally have no mathematical technique to solve that equation. It does not exist. That's why often, not always, but often, more often than not, when we set an equation up where we've got transcendental expressions and algebraic expressions, we have to use some kind of approximation technique. I'm sorry, that's my answer. No, I would not do that on a test situation. I want to see you know your algebra. I said where I can see your solving the equation. Is that okay? I apologize for that, but that's just the honest truth. We can't solve that equation. Either way you write it, I would have gone nowhere. I would have just said, at this point, I give up. Okay, if you're happy with that response, you got to be quiet.
Well, I
Yes.
just, in order for me to see it, I had to set it to 0, where I could see
Yeah.
both sides on.
If you
both
insist.
and then I could look and say, okay, well, what makes that 0? And then the interior had to be. No. I had it at ln 2.
My apologies. You
Yeah.
said x ln2
Yeah.
plus equals ln this. And then what'd you do?
And then I set it to 0.
So you brought everything to one side.
Yeah.
Excuse me, I'll do it correctly. Then what'd you do?
Couldn't you just pick one?
Pick one.
One for X?
Bless you. You know, you're right, because it works. Let me
Yeah.
change the question.
Oh,
Do you see my point?
Yeah.
You got lucky. That's why your author probably typed in the solution something you said was, oh, by inspection. Now by inspection? Heck no. It's not a nice number. Definitely want to use some kind of approximation technique. Sorry. Anything else that I could answer? Yes?
Can you write that like using natural log of e to the power n?
Could you say that one more time? I'm sorry.
Can you write like e to the power natural log of 2 power x?
I see. You meant this stage of the game?
Yes.
You guys, let me play for a minute. Got me where it started. I can. It was just cycling back. It didn't help. It's isolating x. Anybody else on that?
Can you show the setup on 25?
Yes, on 25. So I've got 4 minus x squared. Hold it. You said 25. And I think the other one was linear. Did I write that down? 4 minus y minus x minus 2.
And in terms of y,
Is that the instructions?
yeah,
Got it. I will do just that.
give me my negative signs.
I think first things first, we should graph these pieces. Do you guys mind with the second equation if I just quickly isolate y, just because it makes my life easy? And I think the second equation is merely a line whose y-intercept is 0, 2, and whose slope is positive 1. It looks something like this. Again, here too, you guys, I'm a little sloppy. I'm not unitizing my axes. I think the other one's going to be a parabola, opening downwards, with the vertex at its y-intercept. And I think it looks something like this.
Process, yeah, process.
It wants you to solve it in terms of x on this one.
No, I understand it
Go ahead.
completely.
Oh, okay.
I was just being lazy. I'm trying to graph
Oh,
it
okay,
first, just
okay.
so I got a clear image. You guys, I don't know if I'm being too sloppy. I don't know if I intersect here. I know by observation I could say something like, his x-intercept is at negative 2, 0. One of her x-intercepts at negative 2, 0 as well. Okay, I'm a little off, big dots. But you know, if you couldn't see that, don't worry about it. How you find these 2 points of intersection? You set these two beats equal to each other anyways, wouldn't you? That gives me an x squared plus x. Is that minus 2? Is that an x plus 2 times x minus 1? So I guess my 2 points of intersection are indeed located at negative 2, 0. And positive 1 comma, can I finish this one? I think I might need this. When x is 1, y is 3. Oh, by the way, like I said, this y-intercept is also the vertex of the parabola. But if I'm being asked, can I rephrase all this? If they're entirely up to you, would you compute the area between these two curves by looking at vertical rectangles or horizontal rectangles? What would be easier? Why?
Because it touches.
Because one interval. But they're twisting my arm saying use horizontal rectangles. Why does that make my life more difficult?
Because you have the same equation on the top down here yourself.
Because I got two different curves. When you look at the rightmost extremes for those horizontal rectangles as you slide from bottom position to up position. Can I put them in? All right, I'll just put one in. Red pen. Here's a horizontal rectangle. And let me think of this point right here as x of I comma y sub I. And I'll think of this point right here as x of I, have a bar, comma y sub I bar. I'm just being goofy with my notation. Call it whatever you like. Now, do you guys not agree that to compute the area of this rectangle, I'm going to look at delta x times something else? Yeah, I don't agree either. I think I'm wrong. If you look at the infinitesimally small dimension, it's in the vertical direction. So I think, vertically speaking, I'm dealing with a small change in the y direction. So when I take a limit of Riemann sums, I think eventually that's going to become a dy in the integrand. And so I think everything's going to have to be expressed in terms of y. Can we do it? I know I'm not answering the question yet. I know I haven't even written the integral yet. But let me just play with these lines in my picture. I know I've got that line's equation. But since the integral is going to involve the variable y anyways, can I just, when I write down the equation to describe that line, isolate x over here? I think it tells me x is equal to this. I think for this curve right here, solving for x, doesn't that give me the square root of 4 minus y? Is it plus or minus?
Yeah.
You know, you're right in general, but if I merely look at the portion of this parabola in the right-hand plane, I think I've done it. If I look at the portion of the parabola in the left-hand plane help me with this. Negative root. 4 minus what was y. Are you guys with me so far? Okay, let's do it. I think then, to compute the area between those two curves with my arm being twisted, integrating respect to y, in other words, looking at those horizontal rectangles, humor me. When this rectangle, vertically speaking, is positioned below y equals 3, I think the rightmost extreme is a line, the leftmost extreme is this portion of the parabola. And so I think the horizontal length of that rectangle is nothing more than my x sub I minus my x sub I bar. Which, by the way, is nothing more, well, like I said, than the x coordinates on the line, which are y sub I minus 2, minus the x values on this curve in terms of y, which are going to be a negative root 4 minus y sub I. So I think the first integral is going to have an integrand's position of y minus 2 plus root stuff. I'm integrating respect to y, and my bounds of integration are from -2 to +1. No, they're going to be the y values of those points of intersection from 0 to +3, I agree. However, notice when I add the next integral with where the y values are ranging from one extreme of 3 to another extreme of 4, the bottom curve doesn't change. I say bottom, I really mean the leftmost extreme. It's going to stay at minus a negative root 4 minus y. It's just that I think the rightmost extreme x values are going to change, because now they're on the positive portion of the parabola. And I think x sub I is going to be described by the x values on that portion of the parabola, which is also described by root 4 minus 1. Or shall I say, got this integral, everybody, I'm not changing anything with it. Plus this integral. You guys, so far, is everything okay? Because I think this is the challenging portion of the question, is setting up the integral. Are you okay with it so far? Sir?
Would one of the curves be negative?
You know what it is? It's just that I was subtracting off that negative portion, and so subtracting off the negative portion gave me addition both here and here.
Okay.
Now, I really did incorporate it.
The negative one is the left-hand curve?
It is a left-hand curve. That's why x is described in terms of negative principal root of 4 minus 1. But sir, the negative sign, in a sense, you can't see it because it got absorbed through the subtraction process. I subtracted off that negative portion. That's why it became addition here and here. Come on, you guys attack me. Anybody else? Then do this. If this really were a test question, I probably wouldn't ask you to finish, right? Because, you know, the integrating is beyond the scope of this part of the course, right? Right? No, quite the contrary. You guys can deal with this piece of cake. You're just going to make a use of. To which integral?
4 minus y.
Yeah, the second one, not the first one.
You could do the first one too, if you want to.
You know what? I take that back. You're right. You could. I just meant I wouldn't. I probably would have split this up into two integrals first.
Yeah.
The first one's a piece of cake. The second one, make a use of the same use of you make over there. I'm exaggerating a little bit, you guys. You don't have to listen to me. You can keep this as one integral, commit to use sub everywhere in here. It still works. I'm just saying I probably wouldn't have. It's up to you. Linda, you asked, is that okay? Sir?
You just double if you do half of it, though, can't you?
Unfortunately not, because in this
Well, no,
picture
the
there's no
second part.
symmetry.
Well, there is in the second part.
You know, you've got a point. He's saying this. Watch my green colored region right in here. Is it not true that inside this big green circle, that the area this beast describes the area you see in green? The only problem is that I'm integrating respect to y. There's no convenient way of doing it just because I'm integrating respect to that variable. And I confess, if I were to integrate respect to x with vertical rectangles, there I'd exploit the symmetry and say, well, I can integrate from 0 to 1 and double the result. Unfortunately, because I'm integrating respect to y, sliding these rectangles up and down to those extremes, I just can't exploit that symmetry and write it.
You can't take it from the y-axis to the...
Now, that's true. You can exploit the symmetry if you want to change what's in the integrand's position. I'll agree to that. But in terms of the balance of the way it's written, I couldn't. And if you want to exploit what's in the integrand's position, you could do this. That's a different kind of exploitation of the symmetry. That would work. It's just not as quick and easy as with the x direction.
So draw from the y-axis your rectangle. No,
Yeah, and then
the
go
right
to
hand,
that.
yes, yes,
Now, this is actually described by the integral I've changed. It's just that I've changed what's in the integrand's position.
right.
Yeah.
That would
Yeah,
work just
that's,
fine.
that's how I said it.
You guys attack me. Anything else to get rid of this one? Is there anything else in the homework? All right. Okay. If there are any other questions, are you guys ready to show me you know your stuff? Oh. You know what? Neither am I. So let's see if this works. My wife doesn't like computers, but I forgot she quiz. Let's see if she's able to send me